I am Kirti Vasan, first MSc Applied Microbiology. My topic is Flagella. First of all, what is Flagella? Flagella are composed of subunit low molecular weight protein, flagellin 20 to 40 kilodalton arranged in helical manner. Flagella is a part of microbe. Major work is motile, host and host attachment. Bacterial flagella are hair-like thin helical appendages 12 to 13 nanometer in thickness and 15 to 20 nanometer long. Flagella several times of longer than the bacterial cell. Most of the organisms that produced capsule are non-motile. None of the cocci of medical importance is motile. Arrangement of bacterial flagella. Several types of bacterial flagella arrangements. First, atrichus. No flagella is present. Example: spirochetes. Monotrichus. One polar flagella. Example: Pseudomonas aeruginosa. Lopotrichus, a bunch of polar flagella at one or both ends. Example: Pseudomonas fluorescens. Lopus means Greek for a crest. Amphitrichus, a single flagellum at both poles of the organisms. Example: Aquaspirillum serpens. Amphi means Greek for at each end. Peritrichus, flagella all over the surface of cells. Example: Salmonella typhi. Peri means around. This is the image of flagella arrangement in bacterial cell. Atrichus, no flagella in bacteria. Monotrichus, single flagella in bacteria. Amphitrichus, double flagella in both in bacteria. Peritrichus, overall cells arranged in flagella. Lopotrichus, a bunch of flagella arranged in one end. Cephalotrichus, a bunch of flagella arranged in both ends. This is the image of microscopic observation flagella. Structure of flagella. A flagellum is a hollow, rigidity cylindrical composed of three parts. First, a basal body, second, a hook, and third, a filament. Some gram-negative bacteria have a sheath surrounding the flagellum. The filament is composed of protein flagellin and is a hollow tube 20 nanometer thick. It ends with capping protein. The basal body consists of protein rings that act as a bearings. This is the image of flagella in attached with the bacteria. This is the basal body, cytoplasmic membrane. This is the hook attached with outer membrane and periplasmic layer. This is the rings, bearings to use of motile. Next, difference between gram-negative and gram-positive flagella arrangement. Gram-positive. Two basal body rings, one in the peptidoglycan layer and another one is in the plasma membrane. Four basal body rings, L ring associate with the lipopolysaccharide, P ring associate with the peptidoglycan layer, M ring embedded in the plasma membrane, S ring directly attached to the plasma membrane. In presumed that M ring function as a drive plat motor and S ring as a counterbalance stator, will the P ring and L ring act as a bearings or bunchings? This is the gram-negative bacteria. This is the four rings: L ring, P ring, S ring, and M ring. This is gram-positive bacteria. This is the two basal body rings. Movement of bacteria. Bacteria propel themselves by rotating their helical flagella in corkscrew-like a fashion. The direction of rotation of flagella determines the movement of the cell. Anti-clockwise rotation of monotrichous polar flagella result in a forward movement termed act as a run. Clockwise rotation of the flagellum result in a random tubuling motion. Peritrichous bacteria move in a similar fashion of where the bundling of the flagella during anti-clockwise rotation result of run and clockwise flagella rotation causes a bundle distribution of resulting tubuling. The speed of rotation of the flagella is 200 to 1000 rpm. This is the image of movement of flagella. This is the clockwise, this is the anti-clockwise. This the bunch of flagella move to run movement of bacteria. The rotation of flagella is driven by the proton motive force. The rotor transport protons across the membrane and turn to the process. Demonstration of motility. Some tests of use bacterial motility. Direct observation of motility, hanging drop method, phase contrast microscope, and dark field method. Motility test medium is semi-solid agar. Agar percentage is 0.3. Flagella staining. Leaf staining. This is the Leaf-Funson flagella stain. For the Leaf-Funson flagella stain, tannic acid and the dyes from a colloidal precipitate that went to absorbed by flagellum cause into the increase in a diameter become colorized at the amble to viewing by light microscopic. This is the flagella staining, Leaf-Funson staining result. Thank you.